Okay folks, we're going to carry on looking at volumes this week. Last week obviously we were just looking at cuboids, cubes and cylinders. And we're going to take it on a little bit further this week. Okay, so we're going to look at three different types of shapes really. We're going to look at prisms first of all, and you'll probably notice there's a wee cylinder snuck in there, but it is a type of prism and that's going to help us think about this. Okay, we're then going to look at pyramids, okay, and this is definitely getting on to kind of level 4 plus work, okay. And the cone there is a special type of pyramid, and we're going to look at a sphere, okay, and you'll have, in the textbook pages, you'll have kind of basic questions, just working out specific volumes, and then you might have some that are a wee bit more problem solving, and if we need to ask for help with those, we can, okay. So, the three formulas you do not need to memorise, folks, okay, so we're going to learn three formulas this week. The formula for the volume of a prism is going to be volume equals area times height, and we'll talk about where the area and the height are going to be in a wee minute or two. The volume for a pyramid, okay, is actually very, very similar, but it's just got a third in front of it. So the volume is going to be a third of the area times the height. Okay, so all we do is work it out as if it was a prism, but then divide it by 3. And then the last one, okay, the volume for a sphere is a wee bit more complicated. It's the volume equals 4/3 pi r cubed. Okay, now the last two in particular, guys, are really kind of moving on to beyond where we need to be, but I think you're going to be able to cope with them. But if you're struggling with them, concentrate on all the prism work to begin with, because that's really what's going to help you as we move into 4th year in particular. Okay, so these three pictures here that we've got, so this one here, and this one here are all prisms. Now, what is the definition of a prism then? Why are these three prisms? A prism is something that has what we call a cross section. So here it would be the triangle. Okay, oh, that's not what I wanted to do. On this next one, it would be the hexagon at the front here. Okay, that's your cross section. Okay, or on the cylinder, it's the circle. Okay, now what do we mean by a cross section? Why is this called the cross section? If you think about it, if you cut through that shape anywhere across either the horizontal that way, okay, or if you cut through it kind of like this, okay, you would get that same shape again. The way I always think about it is it's like a stick of rock. Don't know if you know what I mean by that, like a stick of rock that you get at the beach sometimes that's got like the name of a place through it, and no matter where you cut it, that little picture or that name stays there. Okay, so that's what a prism is. Okay, that's what a prism is. So when we're asked to work out the volume of a prism, okay, we've already talked about the fact the formula is the volume equals the area times the height. Okay, the area is the area of that cross section. So in this first case, it'll be the area of the triangle. So if I tell you that the area of that triangle is 15 square centimetres, then that's going to go in there. And then the height is this distance here, or sometimes we might think about that as the length, depending on what way up the prism's sitting. So I'm going to tell you that that height there is 20 centimetres. So to get the volume, we're doing the area times the height, so we're just doing 15 times 20, and we'll get our answer, which will be 300, and we'll put in our units, remember, so cubic centimetres. And sometimes you'll be given that area, so I've just told you the area there was 15. Sometimes you might need to work it out if it's a shape that we can work out the area from, which is why we did areas a couple of weeks ago. Okay, because sometimes eventually you might need to use that knowledge to help you get the area of the cross section. With this next one, the hexagon, we didn't have a formula for the area of a hexagon, so I'll have to give you that area this time. I'm going to tell you that that area is 1.3 square metres, and I'm going to tell you that the height of this is let's say 2.4 metres. Okay, so the volume is the area times the height, So that's going to be 1.3 times 2.4. So again, we grab our calculators. 1.3 times 2.4, which is 3.12. And it's in meters this time, so it'll be meters cubed, cubic meters, okay, for our answer this time. And that's all we've got to do, guys. Now, we did the volume of a cylinder last week, and you might remember that we said that the volume of a cylinder was pi r squared h. But I've also told you that the volume of a prism, and I've told you that a cylinder is a prism, is AH. But I hope you can see the link, because the area is the area of that green circle. And look, that formula that we learnt last week has the area of the circle in place of A. So all we've got, guys, is the cylinder formula is a special one just to help remind you what the area of a circle is, so you don't need to worry about remembering that. So here, I could just tell you that the area of this circle is 20 square millimetres, and the height of the prism is 8 millimetres. And you could actually work out this formula, because I've given you the area and I've given you the height, so we don't need to worry about using pi r squared h. However, if instead I'd given you different information and I had given you that this radius was 3 millimetres or something like that, then obviously you would have to use that formula. So just be aware of that, okay, that sometimes you'll need to use the formula we looked at last week, and sometimes you'll be able to just use the area times height formula. So that's how we work out the volume of a prism. You might want to stop and do that exercise from the textbook first before we move on, but I'm just going to keep going, and next we're going to look at the volume of a pyramid. Okay, so the volume of a pyramid formula, remember I introduced at the start of the video today, and the volume of a pyramid formula is a third of the area times the height. Now again, the area is the area of the base, so here we've got a square. Okay, now this one's quite a good one, because we could work out the area of that square, couldn't we? So if I tell you that that length there is 4, and I tell you that the height is 12, okay, then the area of the square is just length times breadth, which is going to be 4 times 4, which is going to be 16. So we might need to work that out first, but now that we've done that, the volume is going to be a third times the area, which we've just worked out is 16, times the height, which is 12. Okay, so we're basically doing 16 times 12 divided by 3. Okay, remember, if you're working out a third of something, you're dividing it by 3. And we get 64, and this one's in centimetres, so cubic centimetres. Whereas in other questions, like this one where we've got a pentagon on the bottom, we've not looked at a formula for the area of a pentagon, so I would have to tell you that that area is 2.7 square metres, say, and I'm going to tell you that the height is 1.9 metres. Okay, so the volume is going to be a third of the area times the height. So it's a third of 2.7, because that's our area, times 1.9, because that's our height. So 2.7 times 1.9 divided by 3 gives me 1.71, and this one was in metres, so cubic metres. And if the answer doesn't work out nicely, guys, remember you can just round it. Okay, now, last pyramid we're going to look at is again a bit of a special one. It's a cone, okay? So the formula is the volume is a third of the area times the height, but if you're ever looking at posters or textbooks or anything like that, it will sometimes give you a different formula. A third of pi r squared times the height, because that area is the area of that circle, okay, which we know we can get using the formula pi r squared. So sometimes with the circly ones, they give you the kind of formula with that, because most of the time when you're being asked about this, guys, okay, you will be given the information in this way. So if I told you there that that distance was 15 centimetres, and I told you here that that is 9 centimetres. Okay, we need to work out the area of that circle. Now we could do it separately and use that formula, just like we did with the square base pyramid, or we could just say, right, that radius is 7.5, so I'm going to use this formula, 1/3 times pi times 7.5 squared times the height, which is 9. Okay, so we've got pi times 7.5 squared times 9 divided by 3. And obviously we're going to get a decimal this time, guys, because we've got pi involved. So I've got 530.1437 and so on. I would just write that as 530, and again it's cubic centimetres. Okay, so we've looked at prisms, we've looked at pyramids, and then the final one is the sphere. Now, the sphere in some ways, guys, will be much easier. The only thing you've got to remember when we're doing sphere questions is to check whether or not you're given the diameter or you're given the radius. We're always going to want the radius, okay, because the formula is 4/3 of pi r cubed. Now, if you don't have a nice calculator that's got like fractions and stuff on it that you can use nicely, okay, then another way to do this is 4 times pi times the radius cubed, okay, divided by 3. And again, if you don't know where the cubed button is on your calculator, how to get that power 3, the way to type it into your calculator may well be 4 times pi times the radius times the radius times the radius divided by 3. So that looks quite long-winded, but because I'm not there to help you with the calculator, okay, that might be the best way to do it. So we're just going to do 2 quick examples. I'm going to draw some very dodgy spheres. Okay, and with this first one, I'm giving you the radius. So the radius is 5 centimetres. And in the second one, I'm giving you the diameter. The diameter here is 18 centimetres. Okay, so for the first one, the volume is 4/3 of pi r cubed. Okay, now the radius is 5, so this is going to be 4/3 times pi times 5 cubed, or 4 times pi times 5 times 5 times 5 divided by 3, whatever it's easiest to do on your calculator, okay? So you decide what works best for you, okay? If you're not sure, come on to one of the lessons and you can switch your camera on and show me your calculator, and I can probably talk you through how best to use it. But you should get, and this is worth double checking, guys, to see if you're getting on okay with a calculator. I've used the pi button rather than 3.14. Remember, if you use 3.14, your answer will be slightly different. I get 523.598. I'm going to go with 524. I'm just going to round it to the nearest whole number. Okay, so 524 cubic centimetres. Okay, and then for the other one, same idea. Volume is 4/3 of pi r cubed. This time, what's the radius? The radius is half of 18, so it's 9. So 4/3 times pi times 9 cubed is going to be the working out that we need to do. And remember, you can type that into your calculator whatever way you find easiest. It might be that you write 9 times 9 times 9. Okay, and I get 3,053.628. And again, I'm just going to round that to the nearest whole number. So I'm going to round that to 3,054. And again, that was in centimetres, so cubic centimetres. Okay, so that is the volume work that we're looking at this week. We'll look at it in lessons as well, and just give me a shout if there's anything you want me to go over again.